What if we took the entire observable universe, every star, every planet, every asteroid, every gas cloud, literally everything we can see and even the black holes we can't see, all of it? What if we could put it all in one spot and magically keep it from collapsing into a black hole? What would that look like?
Welcome back, everyone. Today we're going to take a break from the usual moon content and instead discuss the universe. And we're asking the question, does it actually exist? It may seem like a silly and odd question, but hear me out. There's a method to my madness. So getting back to my initial question, what if we took all the matter and energy of the universe, literally everything that came from the Big Bang, and condensed it into one spot? What exactly would that look like? Well, for starters, we have to determine the density of all that matter. After all, putting all the stuff of the universe into one area is a surefire recipe for creating the mother of all black holes. In fact, one of the greatest mysteries of our universe is why all that matter and energy didn't simply collapse into a black hole. And one of the weirder cosmological theories of the universe is that actually it did. And we are, in reality, living inside that black hole. But let's put all that aside for the moment and stay focused on how much stuff the universe has. For our thought experiment, we're going to imagine that all of the universe has been condensed into a cube with the average density of our sun. Some of you are no doubt aware that our sun has an average density of roughly 1,400 kilograms per cubic meter. Simply put, if you took an average chunk of the sun, indeed a cube with each side a meter in length, about 3 feet for us Americans, it would weigh 1,400 kilograms or 3,100 pounds. That's almost exactly a ton and a half. For those keeping score, this is about 50% heavier than a cube of water at sea level, but a small fraction of what the average cube of the Earth weighs. So now that we've settled on a density, that of our own sun, how big would our hypothetical universal cube be? The answer may surprise you. Everything the universe has to offer, or at least everything that we can see, all of it would create a cube-shaped star with each side measuring 1,000 light years in length. Now, if you're anything like me, when I discovered this, I was frankly stunned with how large that is. A cube with each side 1,000 light years long? That sounds gigantic. And it really does. But here's the problem. Our own Milky Way is 100,000 light years long from one side to the other. So a cube would be about this big. And keep in mind that there are at least 100 billion galaxies similar to the Milky Way in the observable universe, to say nothing of all that seemingly empty space between galaxies. But while we're on the subject of empty space between galaxies, here's a fun fact. It's estimated that about half of the universe's total mass resides in those so-called empty spaces as largely starless clouds of gas. But getting back to the point of this video, the universe is so painfully empty that it barely qualifies as a thing at all. I'm going to put a number up on the screen that illustrates what percent of the universe is matter compared to the emptiness we call space. This tiny, infinitesimally small amount of matter represents every person you've ever known, every place you've ever been, and every single star in the night sky. Our primitive minds can't really grasp just how little stuff there is in the universe because we've all been raised on lies. And this lie trumps all the others we were raised to believe. Like magic, Santa Claus, and the Tooth Fairy, the universe we've been raised to believe in is honestly a figment of our collective imaginations. While you've been watching this video, fantastic images of the cosmos have been playing in the background. And while these vistas are beautiful and our hearts soar with fantasies of exploring such a dazzling, beautiful universe, it's all fiction. We've become so used to images from Hubble and the James Webb Space Telescopes that most of us believe that this is how the universe actually looks. But these are images that required light to be gathered for sometimes months, all the way across the electromagnetic spectrum, and then they are further enhanced and colorized by artists. Now, these photos were taken at night. Using longer exposures and gathering more light, photographers can achieve an eerie daytime effect in the dead of night. Now, ultimately, whether you choose to believe in a universe essentially devoid of matter, whose atoms are similarly empty, and whose fundamental building blocks blink in and out of existence, is totally up to you. But I would like to leave you with one last thought. January 1st, 2025, just a mere 4 months from now, will mark a very significant anniversary. It is, for all intents and purposes, our universe's 100th birthday. For on that day, a century ago, in 1925, Edwin Hubble, the astronomer for whom the famous telescope is named after, read aloud a paper that drastically changed our understanding of the universe, as well as our place within it. For you see, before Hubble's announcement, we believed the Milky Way to be the entirety of the universe. Nearby galaxies, even Andromeda, which can be seen with the naked eye, were thought to reside within the Milky Way, perhaps as nearby clouds of stars. But Hubble's discovery marked the birth of our modern universe, a universe where our own galaxy, the Milky Way, isn't the entire universe, but merely one of the billions of galaxies in it. The universe was far larger and emptier than we ever could have imagined.